Okay, Mr. Osborne back. Session 3 of our 5-session fractions lessons. Thanks for joining me. If we go any further, just look at this book, Julia Donaldson, Spinderella. I was reading it to my daughter tonight. And nice treat, actually. It's got some maths in there, so we were able to do that. So she's 5, so but take a look at the book. It's a good book. Right. Let me share the screen and let's get underway with our session. So, as I said, let's move the video up. Get around me, session 3. Okay, today you will need a pencil, paper, a ruler if you have one. I always say this, it's good if you have a ruler. If not to worry. You can cope with that one whilst you're at home. Okay. Here we go, a warm-up, write in the missing numbers on the timetables grid. This is a classic SATs style question. Have a go. You should be able to achieve this quite easily, as you are going to be a master of times tables or division in year 6. 30 seconds, maybe pause the video, then come back to me. Okay, so thanks for coming back. Let's have a look at this warm-up and the answers to the warm-up then. Now I'm going to look at my grid. I can see I've got numbers missing. For me, I'm going to have a look. What's the easiest multiplication that I can do here? And it is 35 divided by 5 is going to give me 7. So therefore I know if I was to do the inverse operation, 7 times 5 would be 35. So the answer that goes in that box is clearly 7. Hope you got that. Then I'm going to be doing 30 divided by 5, which gives me 6. Again, just going to try the inverse operation to check that it works. So 6 times 5 will most definitely give me 30. Okay, now we know we have got 63 here. We don't know what's in this box, but we know that we have a 7 here. So I'm going to do 63 divided by 7, which gives me 9. I'll be happy with that. And then we've still got, let's have a look, we could do 48 divided by 6, which is going to give me 8 in the other box. Okay, hope you got that. Times table is massively important in year 6. So if you didn't manage to get that today, keep practicing your times tables, okay? If you did get it, pat on the back, well done. Let's move on to look at what today's learning will be. Okay, to simplify fractions using common factors. Okay, so we looked at our equivalent fractions in our last session. Now we're going to be looking at how we can simplify fractions down to their lowest form. Okay, now let's take that statement and we'll go to the next slide after a bit of animation, obviously, to just have a delve deeper into what we will be doing. Okay, as ever, I've got some key vocabulary up here, which is always really important just to revisit. We have our numerator and denominator, and I'm hoping by now that you know the denominator is how many parts the whole has been divided into. So we've got our pizza example there, and the numerator is how many equal parts we have. And we can see that we've got 3 equal parts. So we have 3/4 there. Proper fractions is a fraction where the numerator is smaller than the denominator. We discussed equivalent fractions and looked how to find equivalent fractions in our last session, and then bringing us on to what today's session is about, simplifying. So what does what does simplifying a fraction mean? Well, a fraction in its simplest form when the numerator and denominator cannot be any smaller, okay, while still being whole numbers. So a little example there, 2/4 can be simplified into 1/4, okay, and then 1/4 would be the simplified fraction. Okay, let's move on. Hopefully Mr. Osborne will be able to say his words today. Let's have a look. I just wanted to visit kind of multiples and factors because they've been mentioned a few times here, and I just want to make sure everybody's got a good understanding. Okay, a multiple is a number that can be divided by another number a certain number of times without a remainder. Okay, and today we're really going to be focusing on factors. Now, a factor is one or two or more numbers that divides a given number without a remainder. Let's just have a look at this number sentence here. Okay, we have 5 times 4 equals 20. Okay, now we know 20 is a multiple of 4, and we know 20 is also a multiple of 5. Here you can see that 5 and 4 therefore are factors of 20. Okay, this number sentence tells us that 20 is a multiple of 5 and also a multiple of 4. It also tells us that 5 and 4 are factors of 20. So 5 times 4 equals 20, and 20 has obviously other factors. Let's have a look. Let's move on, shall I say. Okay, so quick recap what we know. Have a look at this. What is the whole worth here? 2, 3, 4, 5, 6, 7. Okay, I can hear you shouting. 12. Fantastic. Okay, so that's our whole. Okay, if I was to ask you what is the fraction of green, I'll give you 30 seconds. Quickly shout it out. Absolutely is 8/12 are green. What fraction are we left with then of the whole? We're left with 4/12. And from our last session, we could also say, I hope my video is not in the way, we could also say that we have 4/6 are green and 2/6 are red, as these are equivalent fractions. Okay, just a reminder, equivalent fractions look different but have the same value. Okay, let's move on. Just a quick look at relationships within fractions. Okay, let's look at this relationship with equivalent fractions. Okay, now there's a reason I'm just covering over what we did last time, because the more we do it with fractions, the easier it becomes. Okay, so if I'm having a look at this first relationship here, we've got 2/10 is equal to 6/30, which we know is an equivalent fraction. How do we know it's equivalent fraction? Because it is 3 times larger, and we have our numerator and denominator, okay, both times by 3, okay, and we remember from last time that is the case, so we can have an equivalent fraction. Okay, and again within these fractions we can see that 2 times 10 is obviously a multiple of 5, and 6 times 30, 6 times 5 is 30, and sorry, 2 times 10 is obviously a multiple of 5. Okay, just going to show this in the inverse operation as well. Okay, so if we started with 6/30 and we were looking to simplify this fraction, okay, we could be dividing by 3 to take us to 2/10. We could actually even go down lower than that, obviously, because 10 gets goes into 2 goes into 10. Okay. Let's move on and let's give you a little bit of work to do. After I've spoken, pause the video, a couple of minutes you're going to need. Just write down these pairs of equivalent fractions here and investigate the relationship between these fractions. In the meantime, I'm going to grab a drink. Pause the video. Okay, so you're back again. Fantastic. Let's have a look at the relationship between these fractions. Now, these are equivalent fractions, as we know. And so therefore, whatever we do to the numerator, we must be doing to the denominator. So I've got 3/12 and 9/36. Okay, so to get myself up to 9, I know you know your multiplication. So 3 times 3 would give me 9, and 12 times 3 would give me 36. And then just looking at the relationship between the numerator and the denominator, we have 3/12. So 3 times 4 would give us the 3/12, and 9 times 4 would give us the 9/36. If we're to look at this in the inverse operation, it's exactly the same, but in reverse, as you might think, and we're dividing the numbers. Okay, have a go at this, the number explosions. Don't forget, I've taken the 6 over to the left, taken the 18 over to the right there, and then what you're looking for is the common factors that you will find in both numbers. Pause the video, have a go for a few minutes, then come back. Okay, so you are back, and I asked you to find the common factors of both 6 and 18, so then we could basically find the simplest form of the fraction 6/18. So I'm going to have a look at 6, and let's have a look. An explosion there already with nothing in it. So 1 times 6 is obviously 6. We have 3 times 2, which will give us 6. And they are the factors that make up 6. Okay, fantastic. Now let's move on to 18 to find the highest common factor of 18. So we have 1 times 18 would give us 18. We have 2 times 9, which would give us 18. We have 3 times 6, which gives us 18 as well. Now let's have a quick look. So obviously both numbers will have 1. Okay, both numbers have 2, both numbers have 3, and here we go. The highest common factor within both of these numbers is number 6. Okay, now remember the process from last time. We used the highest common factor to then divide the numerator and the denominator by to give us the simplest form of the fraction. Here we go, nice animation. 6 divided by 6 will obviously give us 1, and 6 divided by 18 will give us 1/3. Okay, so hope you managed to have a good go at that. Okay, if you were kind of a little bit uncertain, get a parent to maybe write out some fractions for you and have a go at just exploding those fractions. Okay, I think what you'll find here is the multiplication knowledge is essential when exploding and finding common factors. Okay, let's move on. Oh, here we go, another animation, simplest form, there you go. Okay, using the highest common factor to find the simplest form. Now I just wanted to go over some vocabulary here. So a unit fraction is a fraction where the numerator, okay, so our top number is number 1, and the denominator, bottom number, is a whole number. Okay, this fraction is in its most simplest form. So as a unit fraction, it cannot be any smaller than this. Okay, it's known as a unit fraction when we have 1 as our numerator. Okay, and I'm sure you will see there that the highest common factor for this fraction is 1. Okay, we've exploded the numbers, so I've got my 1 here. There you go, it's 1, and then I've got my 3, so 1 times 3, so obviously I've got my 2 factors there, but 1 is the highest common factor. Okay, we happy with that? I hope we're happy with that. Mr. Osborne is trying not to confuse you. Okay, so just so you know that this is known as a unit fraction, and a unit fraction is where the numerator, top number, is 1, and the denominator, the bottom number, is a whole number. Okay, fantastic. Have a look. These are all examples of unit. Oh, let me go back to unit fractions. Okay, 1/5, 1/3, 1/8, 1/25, 1/374th. Okay. Okay, so let's have a look at non-unit fractions. Okay, now we just looked at unit fractions and we learned that the numerator is always going to be 1. Okay, so quite simply, a non-unit fraction is where the numerator, the top number, is greater than 1. Okay, so 2, 3 possibly. The denominator, the bottom number, can be any whole number. So here we've got an example, 2/5. Could I make that into a simpler form? Well, just as an example, if I tried to divide by 2, I could end up with 2.5, which doesn't work because we need a whole number as our denominator. Okay, so that does not work. So therefore 2/5 is a non-unit fraction in its simplest form. Okay, so just remind you, if we have a unit fraction, we have 1 as our numerator. Okay, a non-unit fraction will be greater than 1, for example, 2/5. Okay, let's move on and give you some work to do. Okay, here you go. Here's a task for you. Exploding fractions again. Identify the non-unit fraction in its simplest form. So you've been given 3 fractions here. I'm asking you to identify the non-unit fraction. So remember that the non-unit fraction is definitely not got a 1 on the top of it, but it is in its simplest form. Have a go at this. Pause the video. We'll come back to me in a couple of minutes and we'll work through these together. Okay, back again. Is so strange for me because I don't pause. I have to go quiet for a little bit and then pretend you've come back, but I'm glad you're back. Okay, so let's have a look. So 1/5, is that a non-unit fraction? We know that's not a non-unit fraction, and we know that that is a unit fraction and it's already in its simplest form. That can go no lower than 1/5. Let's have a look at 2/6. Okay, now if we look at 2/6 and we do our factor explosion here, I can see that we got more. Yes, we have. Brilliant. So if I take the 2, that can be exploded into 1 times 2. And if I take the 6, I've got 1 times 6, or I've got 2 times 3. So therefore, we've got a highest common factor here of 2. So we know that this could be divided by 2 to give us 1/3. Okay, and then I hope you got that. And then let's have a look at this. This is a non-unit fraction. You know, these 2 numbers cannot be simplified, so therefore that is our unit fraction in its simplest form. Okay, hopefully you got that. Give yourself a pat on the back if you did. I'm sure you did. And let's have a look. We're going to move on to some independent tasks for today. Okay, now Mr. Osmond has spoken a lot today. Okay, if you've not picked it up on the first time, rewind back. Can you rewind or go back and have a look before you attempting these independent tasks? Okay, but I'm sure you've followed, and from the knowledge that you've already gained in a few sessions before, these should be fine. Okay, it says find the simplest form of these fractions and identify if it is a unit or non-unit fraction. Okay, remember, we're going to explode these fractions to find the highest common factor. So taking 12, find the factors, take 48, find the factors, find the highest common factor, and then divide 12 over 48 to give you the answer, okay, in its simplest form. Okay, do exactly the same with A, B, and C, okay, and then tell me if it is a non-unit fraction as well. Okay, this here, number 2, we have a question, true or false, the following, I've put a capital there. The following fractions are reduced to their simplest form. Okay, so what I'm asking you to do here is have a look at the visual, okay, work out what fraction that is, and then work out if the following fraction is the simplest form of that fraction. Okay, so you may have to do a little bit of counting up to work out the fraction there, okay, but give it a good go. And then we've got one more independent task over, so I'm just going to show it to you and then talk through this. So here we set got a little bit of a chart. Use the highest common factors below to help complete these simplified fractions. Now you've been given 4 numbers here, okay, and these can only be used once, okay, in each of these calculations. Now what you should end up with is your fraction that has then been simplified, okay? So for example, if you were to choose the 3, does that fit into both? Is that going to be a factor of your number, the highest common factor? Okay, bit tricky, give it a good go. Okay, I'm just going to, yeah, good, that's not got the answers on. Okay, so that's our first 2 independent tasks. Give them a go, come back, give all 3 a go, then come back. Okay, and then we'll go through the answers together and have a little reflection on how you've gotten on. Okay, pause the video. Okay, so you're back. Hopefully you got on well. I'm sure you did. Okay, you're year 6 and a great mathematician. Okay, so let's have a look. Find the simplest form of these fractions and identify if it is a non-unit or a non-unit fraction. So remember what we did. So with the 12, 48, we would have taken 12, we would have found the common factors, taken the 48 and found the highest common factor between both those numbers, okay, which is 12. Okay, hope you found that. And then we would have divided both numbers, numerator and denominator, down, okay, to give us the simplest form, which would be 1/4. Okay, so hope you got that. Okay, if not to worry, there's 2 more chances. Okay, so let's have a look at B. Oops, we would have done exactly the same process. You may have noticed the relationship as well between the 12 and 48 and the 9 and 45. Mr. Osborne's been generous. Okay, and we're going to be divided 9 by 9 and 45 by 9, which would obviously give us 1/5. And then slightly more trickier, but if we look at 14 and 35, if I know my times tables, which I'm hoping I do, I definitely can see these can be divided by 7, and it would take us down to the simplest form, okay, which is 2/5. Now I just want to go back because there's kind of 2 parts to this question, is identify the unit and non-unit fractions. Now, with your great knowledge, you know that 1 in the numerator is going to give us a unit fraction, so we can see A and B are unit fractions, and C is a non-unit fraction. Okay, fantastic. Here we are on number 3. Let's have a look. Use the highest common factors below to help complete these simplified fractions. So what I'm going to look to do is obviously have the same common factor, highest common factor, in both the numerator and denominator to make sure that both squares are of equal value, obviously, because we know in our relationships with fractions, whatever's happening to the numerator must happen to the denominator. So I'm going to divide down. 21 divided by 9, that's not going to work for me. 21 divided by 3, which would give me 7 here, but then 4 times 3 going up would give me 12. That wouldn't work. So I'm hoping you've got this, and let's have a look. 21 divided by 7 would give us 3, and then 4 times 7 would give us 28. Okay, that would be absolutely fantastic if you got that. And then we know that the highest common factor for both those numbers is 7. Cross off 7 because you're not going to use 7 again. Okay, slightly easier, I'd say this one. Have a look. What do you think? 35. I'm looking at 9. I know that's not going to work. 3 is not going to work. Therefore, it can only be 35 divided by 5 equals 7. And 3 times 5 is going to give us the 15. The highest common factor used there was 5. And we're really whittling it down here. So 6 over something equals 3 over something. We absolutely know, I'm sure you know, that 9 is not going to work. Therefore, 6 divided by 3 gives me 2/3. And then 3 times 3 would give me 6/9. Okay, and then we don't need to go through the last one. As you know, the highest common factor will be 9. And there we go. Okay, hope that was good for you. I'm going to leave it on that slide for a little bit longer because that was quite a big question and you might just want to double check your workings. Okay, fantastic. So let's have a quick recap. Okay, today we simplified fractions using common factors, the highest common factor, in fact. Okay, we did our factor explosions. So we took our fractions, we exploded the fractions to look at the common factors, and then we were able to divide that fraction to then find the lowest, the simplest fraction. Okay, next time we shall be looking at comparing fractions less than 1. Thanks for tuning in. There we go. Now we can say goodbye. Goodbye. See you next time.